Today we're going to be talking about relations and functions. Our goal for today is to determine whether a relation is a function and also to find the domain and range and use function notation. So the first thing is we need to know what a relation is. A relation is just a pairing of numbers in one set. So what I mean by that, and this is how we represent a set, is it's just all the ordered pairs in a set. The domain is all of the x values in a relation. So if we look at this example that I wrote up here, remember an ordered pair goes x comma y. So the domain of this relation would be 3, 4, and 6. It's all of the x values. The range are all of the y values in a relation. So in this case, that would be 2, 5, and 3. Now, a vertical line test is a way to check to see if a relation is a function. And what it's saying is if you draw a vertical line through the graph, if it passes through more than one point, it is not a function. Now, function notation is written as f parentheses x, and we say it as f of x. So let's just go to some examples. Here, it says identify the domain and range of the relation and represent the relation as a mapping. So the domain, remember, is all of your x values. Now, number one, we see that the x values are 3, 3, 2, 1, and -4. If any of your x values repeat, we do not write them twice. So when I write out the domain, I'm going to write 3, 2, 1, and -4. My range are all of my y values. So I have 7, 8, -4, 9, and 1. Now represent the relation as a mapping. A mapping, what it does is it draws two ovals . In the first oval, you put all of your x values. Just like the domain, if any of your x values repeat, you only write it once. So I'm going to write 3, 2, +1, and -4. Then in the second oval, we write the range. So 7, 8, -4, 9, and 1. From there, what you do is you draw an arrow from the x value to its corresponding y value. We call the x value the input, the y value the output. So like the first ordered pair is 3, 7, so I would draw an arrow from the 3 to the 7. Our next one is 3, 8, so I draw an arrow from the 3 to the 8. 2, -4, 1, 9, and -4, 1. So example 2 is the same thing. My domain is 6, 5, 1, and 7. My range is -7, -8, 4, and 5. So my mapping, I have 6, 5, 1, 7, -7, -8, 4, and 5. My first ordered pair is 6, -7, so we draw arrows. 5, -8, 1, 4, 7, 5. So let's look at the next example. This one says identify whether or not the relation is a function. Explain. Now the first thing we're going to do is we're going to draw our ordered pairs as a mapping. So just like before. This will help us see whether or not something is a function. So I have -1, -2, 4, and 7. So remember, the first oval is your input, or all of your x values. You could even put an x at the top. Now my output, or my y values, go in the second oval. So I have 1, 2, -4, and -7. So I draw my arrows. Now, a relation is a function if one input has one output. What that means is if every x value only has one y value. So I can tell from my mapping that every x value has one y value because there's only one arrow going from each of my x values. So this is a function, yes. And the way I explain it is one input has one output. So it's basically the definition of a function. So example 2, I have 4, 5, 7, and 5 again, so I don't rewrite it. The y values, I have 6, 1, 2, and 2 again, so I don't write it twice. Now I draw my arrows. 4, 6, 5, 1, 7, 2, 5, 2. Now this is not a function. The reason is because one of the inputs has more than one output, and that input is 5. You can see that the arrow 5 has an output of 1, 5 also has an output of 2. So since our x value goes to two different y values, it is not a function. So the way I would explain that is one input has two outputs. And more specifically, if you're confused, it's 5 goes to 1 and 2. So that input has two different outputs. All right, let's move on. Another way to check if a relation is a function is to use the vertical line test. If I have a set of ordered pairs, the first thing I'm going to do is plot them on my coordinate plane. So 0, 2, 1, -1, -1, 4, 0, -3, and 2, 1. What the vertical line test tells me is if I draw a vertical line through any of my points, so I just drew a vertical line through one of my points, drew a vertical line through these points, a vertical line through this point, a vertical line through this point. If any vertical line touches more than one point on my graph, it is not a function. So in this case, since this vertical line touches 2 points, it is not a function. Now my reasoning is because it does not pass the vertical line test. So it doesn't pass, I'll use VLT. So the next one, obviously these aren't ordered pairs, this is a graph. But what it's saying is no matter where I draw a vertical line, so wherever I choose to draw a vertical line, if it's a function, it should only cross the point or cross the graph once. So here, no matter where I were to draw a vertical line, it would only hit my graph in one spot. So since it only hits my graph in one spot when I draw a vertical line, it is a function. So this is yes, and I would say because it passes the vertical line test. So that is how you tell if a relation is a function. You either look at the mapping and check to make sure that one input equals one output, or you use a vertical line test if you have a graph. Now let's talk about function notation. So number one, in example number 4, it says f of x equals negative 2x plus 8. So this is my function. It's asking me to evaluate the function for f of 3. This looks harder than it actually is. What the 3 means is to plug in 3 for x. So I would literally take this exact function, and everywhere I see the x, I replace it with a 3. Now, on this side, the f of 3, that is just showing you that it's a function. You never solve that part. That is just function notation. You don't do anything with that. What you do is you solve or you simplify this expression. So I would take negative 2 times 3, which is negative 6, and then do negative 6 plus 8, which is positive 2. How I write my answer is I show that f of 3 equals 2. So my final answer is f of 3 equals 2. Do not solve for f, so do not divide by 3. This right here is just function notation. So again, you would never solve this part. It's just showing that it's a function. It's saying if you plug in 3 for x, you would get 2 for y. So this is my answer. So 2 would be the same exact thing. I would plug in negative 8 wherever I saw an x. And then all I do is I solve the right side. So I would take 3 halves times negative 8, which is negative 16, negative 12. And then I would take negative 12 minus 2, which is negative 14. So my answer is f of negative 8 equals negative 14. And again, function notation is just a fancy way of writing things. It's saying if I plugged in negative 8 for x, I would get negative 14 for y. So 3 is the same exact thing. F of negative 1 equals negative 1 minus 7. I don't solve the function side, I just solve the right side. Negative 1 minus 7 is negative 8. So f of negative 1 equals negative 8. And then the last one. F of 6 equals negative 1/3 times 6 plus 2. So, again, I don't solve the left side. I just simplify the right side. Negative 1/3 times 6 is negative 2. Negative 2 plus 2 is 0. So f of 6 equals 0. And that's my answer. So this was lesson 4.6, functions and relations. Make sure you fill out the Google form, and I will see you guys tomorrow.